All right, here is question number 14. We're integrating. This exponent 6 does not allow me to expand this. So what I hope to see is that the derivative of this is reflected, and that is the hook after I take the derivative. So if I take the derivative of x squared subtract 4x plus 8, the derivative of x squared is 2x. The derivative of negative 4x is just negative 4, and of 8 is 0. I also recognize that I could factor this, and that they both have a 2 in common. So if you factor out a 2, you get 2 times x minus 2. The whole point is that when I take the derivative, think of the 2 and the x minus 2. I can see the hook is actually there for x minus 2. So number 14, I'm going to rewrite it. The 2 I can write in front, and then the x minus 2 is the hook of x squared minus 4x plus 8. And then what's simple about this is, this hook, you can think of it as being removed and just do the anti-power rule. So that means add 1 to the exponent, x squared minus 4x plus 8, add 1, that's 7, and then divide by that exponent. And don't forget the constant. Number 15 is a fundamental theorem of calculus question. So you're given f at x and told to take the derivative of it. So the function is actually an integration. So when you take the derivative of an integration, they undo each other. So we're going to plug in the bounds if they're algebraic. So the top bound, upper bound is, so where there's a t, I'm going to plug in 8x. And then the derivative of that limit, the derivative of 8x is just 8. So you plug in the bound, and then the derivative of the bound is your hook. When I plug in negative 3, a constant, and take the derivative, it's just going to be 0. So subtract 0 is unnecessary. There is your answer. Turn the page. 2 left, 16 and 17. If the base of a right triangle is increasing at a rate of 6 inches per second. So the shape I'm working with is a right triangle. This right triangle is changing over time. So the rate the base is changing is increasing by 6 inches. So it's getting bigger by 6 inches, the base. The height is decreasing by 1 inch per second. So the height is actually shrinking over time. And it says find the rate of the area over time of the triangle. And particularly exactly when the base is 4 and the height is 8. So let's start with the picture. There's my right triangle. I recognize that it talked about area. So we have a base and a height, and the area of a triangle is 1/2 base times height. 6 inches per second represents the base and how the base is changing with respect to time. Increasing means it's a positive number. The height is decreasing over time. So the derivative of the height with respect to time is actually going to be -1 because it's getting smaller. My goal is to find the derivative, the area with respect to time, and thinking, what is that? And that's when the base is 4 and the height is 8. It's okay. Miss Itzel is here. Not Miss Haley. We're doing a little calculus right now.
Hello guys, good luck.
Oh, good.
Bye-bye.
Miss Haley says good luck. All right. So back to the problem. We have an equation to start with. I'm going to take the derivative of that with respect to time. That shows how it's changing over time. So the derivative of the area with respect to time. This is actually a product rule. So what is the product rule? It's the first. So I'm going to take 1/2 and join it in with the b. So 1/2 b is the first times the derivative of the second. Now the derivative of the height, h, is just 1, but there's a hook, and the hook is dh by dt. So there's the beginning part. Then what's the second part to the product rule? So the first times the derivative of the second plus the second times the derivative of the first. So the derivative of 1/2 b is 1/2, but then I need the hook, which is dB by dt, because it's with respect to time. Now I'm going to do some substituting in. So the base we said was 4. The height is changing, -1, it's decreasing over time. The height at this point is 8. And then the base is changing over time. It's increasing by 6 every second. I'm going to simplify this. Half of 4 is 2 times -1 is -2. Half of 6 is 3 times 8 is 24. So if I combine it together, I get 22. We're going to write a good sentence for this. So the question is, find the rate of change. So the area is changing at a rate of 22, inches. So inches squared per second. When the triangle has a base of 4 inches and a height of 8 inches. So the area is changing at a rate of 22 inches per second, 22 inches squared per second, when the triangle has a base of 4 inches and a height of 8 inches. Perfect. Last question. Find the area of the region bounded by that, then some volume questions to go with it. So, number 17. First, we have x equals y squared. The line, I want to find where they intersect so I can graph them properly. So instead of y equals, I'm going to change the second one so it says x equals. So then I can take the two equations equal to each other and solve it. So what is x equal? To get x by itself, you'd add 6 and then make them equal to each other. How do I solve the quadratic? Make it equal to 0. So I'm going to subtract y and subtract 6. I'm going to factor it. So the two numbers that factor are -3 and +2. That means the first factor you get the answer +3, and the second one you get the answer -2. Now those are the y coordinates. To find the x coordinates, you plug it back in. Now both equations will give you the same answer, so it doesn't matter. If I plug it in here, 3 plus 6 is 9. Or if I want 3 squared, it's 9. -2 plus 6 is 4, or -2 squared is 4. But we have 2 points. One point is at 9, 3, and the other point is at 4 and -2. So we're now going to graph it. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. And it's 9, 3. And it's 4 and -2. There's my line, and those points are also on my parabola. Now the parabola is x equals y squared, and you can use -b over 2a, but you can see there's no b, right? It's 0. So when you solve it, the answer is going to be 0. When you plug it back in, it's going to be 0. So this sideways parabola starts with the vertex 0, 0. So now I'm going to draw my sideways parabola. I'm going to shade in the area trapped here. And then question number 1 is to find the area that's being trapped there. So how do I find the area? So first of all, we're integrating, and we're integrating sideways. So we need the y coordinates. So we're going to integrate from -2 to +3. And it's right subtract left. So the right is actually the slanted line, and we're going to write it in terms of y. So it's y plus 6, subtract the left, which is just y squared. I'm going to continue. So I'm going to simplify this a little and put it in order. So we have -y squared first, then +y and +6. To integrate this, we're going to add 1 to the exponent and divide. Again, we're going to add 1 to the exponent and divide by that exponent, and then 6 becomes 6y. We're integrating from -2 to +3. So then the last step, we're going to plug in the upper bound first. Whatever answer that is, we're going to subtract and plug in the bottom bound. I'm not going to simplify that. So that's a good answer. That's not simplified. That represents the area of what you graphed right there. There are two more questions. One has to do with volume with right triangles, and the other is revolving. So let's start with right triangles. To do with volume. So first I need to know the formula for a right triangle, and we just did that one before. The area for a right triangle is half the base times the height. In the question it says, find the volume using right triangles where the height is twice the base. So we know the height is twice the base. To find the volume, we're going to integrate. The bound stayed the same, -2 to 3. I'm going to use the formula for a right triangle, so I'm just going to write it in. 1/2 the base times the height. The base, that represents right subtract left here. So the base of the triangle is right subtract left. So at any time, what would that distance be? Right subtract left. We already did that right here. So I'm just going to use it. It's -y² plus y plus 6 times the height. And the height is twice the base. So I'm going to put in 2 and then write the base down again. -y² plus y plus 6. And that's dy. And that is what you put in your calculator. So if you put in your calculator, I think I already have it in here. This is what it looks like. So -2 to 3.5, you type it in, see if it matches. And you can see the answer is 625/6. Press pause, try it. The last one, so let's separate this. So you have area, you have volume with right triangles. The last one is revolving it. It says now revolve it around x equals -4. So x equals -4 is like here somewhere. The most important part to recognize, it's a washer. So what's the distance from what you're revolving around to the outer edge? So if I go all the way to the outer edge, you can see the outer edge is the slanted line. And that big radius, so it's going to be a big R, little r. That big radius, I'll write it right here, big radius is going to be the right subtract the left. So the right is the line, and I'm going to write it in terms of y, so it's y plus 6. Subtract the left, which is -4. So if I simplify this, it's y plus 10. The little radius goes from this line of rotation here, revolving around, to the front edge. And the front edge is the parabola, which is just y². So the right edge, the front edge, the right is y². Subtract the left, so subtract -4. So this becomes y² plus 4. All right, let's go back here and set it up and then use our calculator. So what's the template for the volume? This time we're revolving it around x equals -4. So they're going to be washers, 2 circles. So it's pi. We're integrating again from -2 to 3. The first radius, the big radius, we said was y plus 10. Subtract the small radius, which we said was y² plus 4. dy. That's it. So use your calculator. We need another set of parentheses when we put that in the calculator. So you try it. I already have it in my calculator, so I'll show it to you. So when you type it in your calculator, that's what it looks like. And you get the answer 1047 0.197. So press pause. See if you agree with me when you type it in your calculator, and you're done. So, good luck. I'm glad you got to number 17. I'm glad you're trying to work on calculus independently from the classroom, and you're going to put your best effort when we do the test. And I know you're going to do great. Mr. G Math, over and out.